Explore manufacturing methods. In this video, we'll set a generative design manufacturing method and we'll identify some manufacturing options. In Fusion 360, we want to carry on with our generative design geometry setup. At this point, we've defined pretty much everything in generative design with the exception of our manufacturing methods. Even though there are some set by default, notice that we still have a pre-check warning. It's telling us that our geometry might be too large to be 3D printed. So let's go into our manufacturing methods and see what we have available. Very first at the top, we have cost estimation. If we include cost estimation, it's important to note that not all of the manufacturing methods and not all of the materials will be included. Only those materials that had the small calculator icon will be used for cost estimation, and only in the manufacturing methods that are supported. We will leave cost estimation turned on for our example, but just note that it is not universally supported for all the materials. Next, the first method that is automatically selected is called unrestricted. This allows the software to explore all of the outcome geometry, and it's going to exclude any manufacturing restrictions. This is great to use in the prototyping process, and especially if you are going to be using the generative design outcome as a basis for another design. If we're going to take this outcome and we're going to base our own design on it, then this would be the best option to use because it doesn't have any manufacturing restrictions. But it's also important to note that even though you are creating a generative design with unrestricted, that doesn't necessarily mean that you can't manufacture it. It just means that it will not be supporting any of the other criteria or constraints from the manufacturing method. Next is additive. And when we have additive, what we're doing is we're looking at several different factors in the build process. With additive, it's looking at things like the overhang angle, it's going to be looking at minimum thickness values, and the direction or the orientation that it's being printed. So if you're designing a part that's going to be printed on a desktop machine using fused filament, for example, there are specific overhang angles that you can support without needing additional material. There are also certain orientations that you might want to include based on the way that your design is set up in Fusion 360. For example, our frame is not really a good candidate for 3D printing. However, the positive and negative X directions would be ideal based on the orientation of the different mounting points for the frame and the suspension. But note that, again, it's problematic and this is really not a good fit for additive. So I'm going to deselect it because that will just increase the calculation time if I include it. Next, we have milling. And when we get to milling, there are three different options that we can have for our configurations: 2.5 axis, our 3 axis, and a 5 axis. When we look at these various options and we compare them to unrestricted, for example, the unrestricted can have overhangs and occlusions in places where the tool just can't get to. When we look at 2.5 axis, we have restrictions on the manufacturing method and the fact that the tool can only access certain areas and it's not going to be blending geometry between different heights, in this case in the Y direction. When we look at 3 axis, it will give us more organic and smooth geometry, and it needs to make sure that the toolpath can access the specific geometry from various areas. But when we get to 5 axis, this is more unrestricted. The 5 axis methodology is really looking at the tool size and the shoulder length and the head diameter of the machine to really see how close it can get into the parts that are being machined. The frame example, again, is not really a good example for milling because it's a very large and complex piece. Now, certain aspects of motorcycle frames are machined, but those are generally welded together or they're used in other manufacturing methods. We have a 2-axis cutting option, and this is very similar to 2.5 axis milling, with the exception that we have no available options to create any different depth cuts. 2-axis cutting also has some restrictions in the fact that all of your preserved geometry needs to be at the same height and the same thickness. This is going to assume that you're using a water jet or a laser machine and that it's working off of a flat plate or piece of material. So again, 2-axis cutting doesn't work for our example and it would be excluded and it would produce a problem. The last option we have is die casting. And die casting has some similar restrictions to additive. It's looking at a build orientation, But instead of doing a build orientation with overhangs, what it's really looking at is draft and the ejection direction. So die casting can be an extremely valuable tool, but for our example, again, it doesn't really work for the frame. We're really looking at more of a conceptual model, so the unrestricted method works best. Having said that, there is nothing that is excluding or restricting us from selecting some of these methods with the exception of two-axis cutting. We could include milling in five axis and we could include additive, but it would just increase the amount of time it takes to calculate our parts. And because we ended up just using unrestricted, I'm going to deselect cost estimation as it's really not going to be an effective metric for us because we're not looking or worrying about manufacturing methods at this point in the design. So once we select OK, let's take a look at our pre-check to see if we still have any problems. It's simply telling us that the study geometry is too large to be 3D printed, and it might affect its ability to be estimated in terms of its manufacturing cost. Again, that's not a problem because in our manufacturing methods, we're not looking at cost estimation or additive, so it's really just a note based on the size of our geometry. With all that said, we really have no other options or things that we need to set in order to solve our study. But before we go any further, let's make sure that we do save the design before we move on.